Hello and welcome again to our next video in this series talking about functions. Talking about a specific topic tonight in functions, and that would be related to variable scope. This is the first asynchronous lesson of the week. It ties into what we will be doing live during our first live lesson of the week on variable scope. We touched on variable scope a little bit. If we declare a variable inside of main is a function. It exists from that point to the final brace of main. So not very far because it's only one line away, but still. That's a local variable. It's local to that function. Much like if you recall back in Visual Basic, when you dimmed a variable inside of a sub, it existed in that sub. If we were to go up top and declare something in this section, that would be a global variable. If we declared x or some other variable there, it would exist from that point throughout every function we have, including main. But something interesting happens, and it all has to do with the way that C++ handles parameters that are passed into functions. Let me show you an example. I'm going to declare a function up here. Very simply, I'm going to call it f, like f of x. Send it an integer, get an integer back, called f. So that's our prototype. Down the bottom, I'll have the definition, int f, int, and I'm going to purposefully call this x. Now, the most important thing to understand here, this x and this x are not related other than the fact that they are called the same thing. Please understand that. This x and this x are only related by the same name. They're not actually the same variable because this variable has scope local to main, whereas this variable has scope local to the function f. So what happens then when I send this variable into here? And that's what this is all about. So let me just say, if I send in f of x, so if I'm sending in 5, the value of x into f, what happens? Well, let's make f do something. I'm going to say return x times 2. So 5 times 2 is 10. And will this give us 10? I sure hope so. Let's try this. Shocking, right? It gives you 10. Exactly what you would expect. So what's the big deal? Like, oh wow, Mr. Ensminger, that's amazing. Thanks for making us watch the video. Okay, I get it. But when I print out x, understand x is still going to be 5. X is not changed. Now, that makes sense because we're returning x times 2. It's not like we're changing x. We're just returning the value of x times 2. Okay, that makes sense. What if I do this? X equals x times 2, return x. Now, 5 times 2 is 10, so x is equal to 10. Return x. X goes back up here, f of x. So it's going to print out 10, right? Has this changed? Oh no, it didn't. That's 10, that's 5. That's my point. My point is that you're making changes to x down here. That change does not carry over back to the original x. You're not modifying that original x because this x has scope local to main. Anything you do to x down here is not kept. It's a copy. We're sending in a copy of this x down here. And again, it's only the same name. It's not the same variable. So we're sending in 5. It's not the same x. So again, we call this passing by value. You're passing the value. You're passing 5, not x. You're passing the value. So any change made to x is not kept when you leave the function, which, well, that's sort of problematic because what if the whole point of the function is to modify the value you're sending in? Let me give you an example. Let's say I make a function called swap. I want to swap 2 integers. So send in 2 numbers, int. Okay. So let's come down here. I'll say int a equals 3. int b equals 7. So my whole goal, I want to swap a and b so that when I see out, when I print a, I want 7. When I print out b, I want 3. So let's try it. I'm just going to squeeze it here so we can see the whole thing all at once. If I say void swap int a, int b. Okay, first, understand that you can't just do this. You can't just do that. The reason you can't just do that is because, let's just plug in the numbers. If a is 3 and b is 7, so what you're saying on this line is let the value 7 set into a. So now a is equal to 7. But the thing is, on the next line, you're saying let a equal b. So 7 goes back into 7. So you're getting 7 for both numbers. So you've completely wiped away the 3. Anytime you're trying to swap two variables, and this is a very common 3-line algorithm in programming, you need a third variable. You need some kind of temporary. So like int temp equals one of the variables. So a, for instance. And then a equals b, b equals temp. So again, what you're doing there is you're saying, okay, store 3 temporarily, and then put 7 into there. So now a is 7, which it's supposed to be. But then you're saying the 3 that's kind of hanging out there, put 3 into b. So it does exactly what we want. And I can prove that if I say cout a, cout b at the bottom of my swap function, it's going to give me exactly what I want. There's 7, there's 3. But the last two numbers, a and b, it goes back to 3 and 7 because, again, the changes aren't kept. I modified a and b in the swap function, but once I leave the swap function, they're back to the way they were. So how do you fix this issue? If you do want it to be kept, if you want the values of the variables modified to be kept, what we need to do is something we call passing by reference, where instead of passing by value where you're sending in a copy, you're sending in the number, you're sending in the actual memory contents. You don't have to go too in depth with this, just understand that what you're doing by doing this is any changes to the variables are kept. Here's how we do it. We're going to go back up here to the prototype, and we're going to put an ampersand following each variable, each parameter type, here and down here. Ampersand, ampersand, the and symbol, it's above the 7. That little tiny change will make it so that now when I run it, look at what happened. Instead of 7337, the changes have been kept. You're passing it by the actual variable. So A is now the same A. B is now the same B. That little ampersand makes all the difference in the world. We'll talk more about what actually happens here in a couple chapters when we talk about memory management, something called a pointer in C++. It gets a little bit messy. But for right now, just understand that the important thing is when you have a function, any changes you make to the variable when you leave it are lost, unless you do the ampersand. Thanks again for watching. Have a great day, morning, night, evening, whatever. Take care.